Dynamic recrystallization, DRX, is a type of recrystallization process found within the fields of metallurgy and geology. In dynamic recrystallization, as opposed to static recrystallization, the nucleation and growth of new grains occurs during deformation rather than afterwards as part of a separate heat treatment. In a stress-strain curve, the onset of dynamic recrystallization can be recognized by a distinct peak in the flow stress and hot working data due to the softening effect of recrystallization. However, not all materials display well-defined peaks when tested under hot working conditions. The onset of DRX can also be detected from inflection point in plots of the strain hardening rate against stress. It has been shown that this technique can be used to establish the occurrence of DRX when this cannot be determined unambiguously from the shape of the flow curve. If stress oscillations appear before reaching the steady state, then several recrystallization and grain growth cycles occur, and the stress behavior is said to be of the cyclic or multiple peak type. The particular stress behavior before reaching the steady state depends on the initial grain size, temperature, and strain rate. DRX can occur in various forms, including geometric dynamic recrystallization, discontinuous dynamic recrystallization, subgrain rotation recrystallization. Some authors have used the term post-dynamic or metadynamic to describe recrystallization that occurs during the cooling phase of a hot working process or between successive passes. This emphasizes the fact that the recrystallization is directly linked to the process in question, while acknowledging that there is no concurrent deformation. Mathematical formulas. Based on the method developed by Polyak and Jonas, a few models are developed in order to describe the critical strain for the onset of DRX as a function of the peak strain of the stress-strain curve. The models are derived for the systems with single peak, i.e. for the materials with medium to low stacking fault energy values. The models can be found in the following papers: Determination of flow stress and the critical strain for the onset of dynamic recrystallization using a sine function. Determination of flow stress and the critical strain for the onset of dynamic recrystallization using a hyperbolic tangent function. Determination of critical strain for initiation of dynamic recrystallization. Characteristic points of stress-strain curve at high temperature. The DRX behavior for systems with multiple peaks and single peak as well can be modeled considering the interaction of multiple grains during deformation, i.e. the ensemble model describes the transition between single and multi-peak behavior based on the initial grain size. It can also describe the effect of transient changes of the strain rate on the shape of the flow curve. The model can be found in the following paper: A New Unified Approach for Modeling Recrystallization During Hot Rolling of Steel. Literature. A one-parameter approach to determining the critical conditions for the initiation of dynamic recrystallization, onset of DRX. Flow curve analysis of 17.4 pH stainless steel under hot compression test, comprehensive study of DRX. Constitutive relations to model the hot flow of commercial purity copper, Chapter 6, doctoral thesis by V.G. Garcia, UPC, 2004. A review of dynamic recrystallization phenomena in metallic materials, latest review paper on DRX. A cellular automaton model of dynamic recrystallization, introduction and source code, software simulating DRX by California, introduction, video of software run.